Okay, so our next speaker is visiting us all the way from Japan. It is Ko Lai from Kyushu University, who will speak to us about the structural and functional analysis of fibrinogen degradation products in fish. So thank you very much. Welcome.
Thank you for having me here, and thank you for supporting me with the travel all the way from Japan to here. And my name is Kolai. I'm from Kyushu University, Japan, and I come from the marine biochemistry lab. And today I will be presenting about structural and functional analysis of fibrinogen degradation products in fish. So the two innate system, complement and coagulation system, are thought to share a common evolutionary origin. Recently, it has gained much attention, especially in COVID-19 and influenza, where these infectious diseases are often related with complement overactivation and thrombosis. And in these patients, the fibrinogen level and its degradation products are often elevated. Teleofish or bony fish, as a primitive vertebrate, provides a valuable model to study their interaction and to trace the conservation across vertebrates. However, in bony fish or in teleost, the fibrinogen degradation mechanism or during coagulation is not underexplored. In human, fibrinogen is first cleaved by thrombin, then cross-linked by factor 13, and then degraded by plasmin. It generates a group of soluble fragments known as fibrin or fibrinogen degradation products. We call it FDPs. In our lab, we previously purified a complement inhibitor that has similar size and sequence with human D-dimer. We found that this inhibitor has a way higher hemolysis inhibition on complement compared to the intact fibrinogen purified from plasma. Based on this, we hypothesized that fibrinogen processing is the key that contributes to the complement inhibitory activity in carp. So to explore this, we have to first purify carp fibrinogen. We adapted human fibrinogen purification method, and we successfully purified carp fibrinogen as shown in this elution profile in the final gel filtration step. On SDS page, there's under reduced condition, there's also 3 of the bands that is consistent to the reported carp fibrinogen subunits. By this rapid and small-scale purification method, we are able to generate this pure and functional fibrinogen. For us to generate polyclonal antibodies against each fibrinogen subunits, we separated each of the fibrinogen subunits carefully and then use it as antigen to immunize rabbit. The resulting anti-sera were tested with Western blot, and each of the antibodies showed subunit-specific detection. This allows us to detect each of the fibrinogen subunits during coagulation or to see how it's cross-linked. So when we induced the coagulation, we see in Western blot that in this result, we can see that this is the original size of fibrinogen subunits before thrombin addition. After induce of clotting, we see a decreased size of alpha chain, which is because of the release of fibrinopeptides, whereas beta chain and gamma chain are cross-linked into several high molecular weight bands. Also, after prolonged clotting, we also see some smaller fragments of beta chains. This result is very different from what are known in human, where factor 13 cross-links alpha chain producing alpha polymers and gamma chain and producing gamma dimers. The results we have showed beta chain cross-linking, which we think it's distinct in fish of the fibrin processing. So further, to produce FDPs, we had to purify plasminogen and plasminogen activators such as tissue-type plasminogen activator, TPA. By this fibrin slide method is also adapted from human system. We successfully isolated this fibrin binding protease and confirmed its function, its proteolytic function by plasminogen-rich fibrin plate. By these purified fibrinolytic systems, our next step, we are able to generate soluble FDPs. And this concludes my research. Thank you.
That's really hard work, so thank you for doing it. I'm curious how this is comparing to studies done with hagfish fibrinogen, which is one step further up the evolutionary tree.
Your question is how the fibrinogen is degraded in
compared to
higher
hagfish.
I'm not sure. I only know in carp is what we saw in this, but I think when I look for papers, there is not much of the paper that focus on how fibrinogen is degraded, so I'm not sure in the a little bit higher vertebrates.
Thank you. I think Russ Doolittle might have worked, Russell Doolittle.
Russell Doolittle.
Doolittle, yeah, might have done those works.
Oh, yes, the Dr. Doolittle. Yes, but it's like 50 years ago.
Well, yes, but they're still
Yes.
valid.
Yes, I saw them.
Yes.
Yes.